All right, the recording has started. Ruben, the floor is yours.
Okay. Yeah, thank you so much for the invitation. Great to be presenting to the experts on active inference. And thank you for both the invitation and the help, especially on the modeling side, to Carl. And special thank you as well to Shamil, with whom this project was very much a deep co-creation, in the sense that unlike it usually happens that one person really takes the lead, we very much worked on this in tandem throughout the whole project. So can everybody see my screen okay, and everything looks as it should? Good. All right. So the title of this talk is Conscious Worlds, Beautiful Loops in Cells and Silicon. And my name is Ruben. And so consciousness may still be the greatest mystery in science. And part of the reason is that there is yet no good reason for experience. We don't really know why it is that we have this rich inner subjective world that we do. So consciousness remains a pretty big problem in science, and this is our sort of attempt at this very large problem. And in fact, I didn't intend to have a go at this problem. So this was very much a accidental theory of consciousness that emerged as Shamil and I were really working on a computational framework for meditation. But it turns out if you want to understand meditation, you end up looking pretty closely at consciousness. And so as we started to come up with some interesting loops and ideas about meditation, we realized, hey, there might be something worth saying about consciousness itself. And so this is how we ended up here. And the basic thesis is this, and then I'll be unpacking this basic thesis throughout the rest of the talk. So a system that is conscious ought to satisfy three criteria. The first criteria is the generation of a world model. So this is what can be known. The second criteria is inferential competition, which is essentially the selection process for what becomes conscious as opposed to what remains unconscious. And the third is the crucial, I suppose, more novel part of our story, which is this idea of epistemic depth. And this is what allows the world model to actually be known. And together they form a beautiful loop, a world model that knows itself. And so recently, Anil and Tim said that active inference provides theories for consciousness science rather than theories of consciousness per se. And I guess what we're also going to try to argue here is that active inference possibly can satisfy the criteria for a theory of consciousness if we add hypermodeling, which is our go at a formal version of epistemic depth. And I think this may turn out to be important for self-supervision and general intelligence, at least conceptually. How accurate any of the implementations turn out to be remains to be seen. But I think we need to think about something like this when we're talking about the epistemic flexibility and agency reminiscent of general intelligence. All right, so how to build a self-aware world model. So this is going to be now the criteria in more detail. So criteria one, a world model. This is super central, so I'll spend a little bit of time on this. A world model, in very simple terms, we can think of as a compression of the causes of our sensory data. So we live in this immensely complex and rich world, and in order to make sense of it with limited resources, in order to act adaptively in the present and in the future, we need to make a model of it. And this ends up, of course, always being a compression because you can't fit the whole universe in your brain. So in nature, even materials can be homeostatic in the sense of maintaining their state, but only organisms are allostatic. And so something unique about our world model is that we sprout this counterfactual tree that allows us to not only represent potential causes of our sensory data in the now, but also across time at multiple levels of abstraction and increasing compression. So our world models are quite extraordinary because the brains that we have are structures that beget structures, compressions that beget compressions, things that create things. And it's really like over our evolutionary trajectory, the richness of our computational powers inside of our heads really allow us to build realities far beyond even what might be out there in the present moment. And so ultimately, we become much less passive information receivers and much more generative, creative systems that can proactively prepare for perturbations and future realities. So nature generates generative life, which is very cool. And in fact, we can say that nature computes computers that compute computers, which is very extraordinary. The question then is, of course, what is how precisely do we create these world models that allow us to survive across time? And for this, I think, and more people, I think, believe that active inference is a promising framework for thinking about how the brain and possibly AI can build world models, and to massively oversimplify it, the brain is making predictions, and through the interface of the body, noticing errors but also through through actions, and then through a complex hierarchy of processing these what ends up being basically uncertainty, these prediction errors over time, we can build a model that is adaptive and allows us to function in the world. But how do we stitch together a coherent world model, right? So we have a really difficult problem in the sense that the various sensory streams of information, auditory, visual, tactile, interoceptive, and so on, are all coming in at different times in different ways. And not only that, we also have this rich repertoire of conceptual capacities that we have to stitch this together into kind of a bounded, coherent world model. And this is extraordinarily tricky and a kind of central problem in neuroscience. And so this is from the first figure in our paper, and this is partially really the standard active inference story, which is that you have various streams of input, including all of the different sensory modalities that I mentioned. And through initially unimodal processing areas of the brain, where these sensory streams are segregated, there's this gradual buildup through abstraction, compression, and binding in more transmodal and multimodal regions of the brain, integrative hubs, so to speak. We get increasingly a kind of unified world model. So taking the kind of separate streams that are gradually combined in the brain in different regions, and then you're able to kind of build this coherent view of reality. And to kind of bring that intuition home, we use this term Bayesian binding. And so, what is approximately going on is that you have a prior. So we're just using an example of the face in this case. So you imagine that you have a high-level abstract representation of the face, a belief that you've learned over your history. And then you have this noisy sensory input, say a face in the dark or so, or you see a face just out of the corner of your eye. But by combining these two bits of information, your beliefs and the data through the standard kind of approximate Bayesian scheme, you end up at a posterior that actually looks clean and makes sense, because when you combine your previous learning with the noisy data, you can make sense of the world. And this is your bound face percept, which is normally, this mixture of sensory experiences, but then gets bound by the help of your abstract priors. And the idea is that this is what we do for our whole world model. So we bind together all this information in the same way that we bind a face. So hierarchical multimodal Bayesian binding permits this unified coherent reality model. And so what I mean by reality model is this whole experience of reality that we have. So we can all kind of tune in to see, okay, I'm aware of the fact that I have a body. I'm aware of the fact that I have a stream of thoughts and all of these different sensory experiences unfolding. And so we don't only have a reality model, crucially, we are aware of it, right? So we can say that active inference satisfies criteria 1. That gives you a good way of thinking about how a world model could be built. And criteria 2 is inferential competition. So obviously some things are conscious and not others, and there's the deep question of why are some things conscious and other things remain below the threshold of awareness. So, for example, we're aware of the three-dimensional experience of this illusion, which is just a hollow mask. But we're not aware of what allows us to perceive it as three-dimensional, nor are we aware of the processes that lead to the fact that the hollow mask actually flips and gives us the illusion of a sticking out mask because of our previous experiences with faces and light and so on. So a lot of processing remains below the threshold of consciousness. And same goes, for example, the classic case of binocular rivalry. So if you present one stimuli to the left eye, another stimuli to the right eye, we're only conscious of either one of those at a time or some sort of mixed percept of them because the brain infers that you shouldn't have the same stimulus in the same spatiotemporal location. So you get this flipping back and forth. But we're not aware of how that happens, right? So inferential competition, there's nothing particularly new about it. It draws on 150 years of selectionist thinking in cognitive science, and GPT-3 frames the history like this, going back to William James and kind of applying evolutionary ideas to the kind of competition between various mental states and their, trying to reach the threshold of consciousness. And you have various kind of iterations of this over the years, competitive neural networks and biased competition, models of attention. So attention has often been, playing this role of selection or gating. And this is, of course, in the context of consciousness, well worked out in global neuronal workspace theory in terms of local representations racing for ignition, where the winner is broadcast into this global workspace, or as Dennett puts it, this is the sort of fame in the brain idea. So the important representations win the competition for ignition. And then this gets formalized, of course, in predictive processing and active inference as precision. So probably everyone here is familiar with the idea of precision, but this is the kind of formal selection, what allows for a formal selection process within active inference. So you have your prior expectations that are have a distribution, and then a kind of confidence distribution, and then the incoming evidence from the world as well. And then it's through combining these you get your inferred estimate. And depending on the weighting of your priors and incoming evidence, your inference, your posterior can look quite different. So for instance, if you have exaggerated beliefs about evidence precision, that is, you're just paying attention to the evidence out there, but not your priors, then you might miss a camel that is actually there if your priors were working, but you won't see it because you're only so heavily weighting the input in this case. And on the other hand, if you have exaggerated beliefs about your priors, then you'll hallucinate. Even when there's not a camel there, you will actually potentially hallucinate a camel. And so this precision-weighted melee allows you to instantiate inferential competition. So we can also say that in active inference, we have a mechanism for this competitive process that allows for the selection of particular posteriors that end up making it into the reality model that we experience. Okay, so now we're up to criteria 3, and this is where it's the more novel stuff, potentially. And so the question remains, why does the reality model know that it exists? It's not just that we're generating the reality model. Somehow we're aware of the fact that we have this model of the world. So all of our visual phenomena, sounds, our narratives about ourselves and thoughts and emotions, smells and actions and so on, all of this, we can either be aware of it or not, right? We can somehow reflect on our world model. And, often attention plays this role, but actually we can also realize that we can be aware of our attention. So I think you need something more global and ultimately more recursive to allow you to know the whole world model, including changes in our attentional states. So what we mean by the term epistemic depth is a capacity or continuum so deepening of knowing or awareness that can be more or less active. Or intense or clear. So mindfulness is a good example. So you can be very unmindful. Let's say you're driving a car and you're off in your thoughts, or you're listening to a podcast or something. You obviously still got a reality model that's allowing you to navigate the world, but you're not aware of the fact that you're driving basically at all, and you're not encoding it into memory. And so if you become aware of the fact that you're driving, suddenly there's epistemic depth, right? There's deep knowing of your world model. And this can be extremely dull, like in the case of as you're just about to fall asleep, or it can be exceptionally clear, as in the case of like meditative states or mindfulness. So our solution for how epistemic depth might be achieved is to recursively share your world model with yourself. And this creates the beautiful loop. And so just to give you an intuition for this, which we'll go into more detail, when we speak out loud, we produce sounds, and at the same time, we hear those sounds and their meaning. So we hear our own voice in what we are saying. Therefore, our output, our voice, is also our input sound. So these kinds of loops are everywhere, and they're kind of all over the hierarchical active inference system anyway. But what we're saying is that as we generate this global unified reality model, there is also a loop there, in the sense that our model of reality becomes an input to ourselves. We discover ourselves as a world, and then that world is what we can explore and interrogate and update and so on. And this is really, I think, unique of biological minds at this moment. I don't see any kind of instantiation of this in AI at the moment, this capacity to generate a coherent world model, then reflect on the world model in a kind of global way. And so now we can put these three things together. So first you have it's all happening in the hierarchy. So we have this it's all happening there together, but we're going to separate it out just for the sake of illustrating the kind of conceptual point, where you have this complex hierarchy of processing that allows you to have this create an understanding of the causes of your sensory data. There's an inferential competition unfolding within this hierarchy, where only certain winning inferences bind into the global posterior, the world model, and there's this pressure for coherence into the world model. And so through this inferential competition, we get this coherent, bound together model of reality. That's kind of a dance between our priors and the input to create this coherent posterior that we then navigate. And then, as with everything in the system, it's shared with the system itself. So this is epistemic depth. The world model is reflected into the abstraction hierarchy. The broadcast information enhances the binding process by upweighting representations that cohere with the unified world model. So this world model now also provides the constraints for future iterations of inference, because you of course want all future iterations to cohere with your current world model. This is what allows like ongoing stability of our experience to persist over time. And again, to kind of bring this intuition home, it can be helpful to think of epistemic depth as parallel to precision and abstraction. So we have precision here on the y-axis, abstraction on the x-axis, so the degree of abstraction and the amount of precision. You can imagine that there's a certain amount of precision and abstraction is required to be even potentially aware. And then we have this space of things that are in our reality model that can be known, including background sensations and focused object and mind-wandering states and so on, so all the potential states. But it's epistemic depth that allows the actual awareness of these states. So for example, if you take thoughts, when thoughts are mindful, we're aware of them, but and we can be aware again of our transitions in our attentional state. But if we have focused thoughts, we might not even know that we're thinking them, right? We might be having them, but we might not be aware of them. And certainly we're not aware of, for example, background sensations unless we bring attention and epistemic depth, we think, to them. So the shirt on your back, for instance. Okay, so how to model epistemic depth using active inference? I think, this is an open problem, and base at the base level, this is a kind of conceptual idea with a computational backbone in the sense that we're trying to think through it computationally. But we can try now to think about how to model this. And it can look very different in brains and in different AI systems, and I'll kind of give a kind of broad sense of what that might look like. So we propose this idea of hypermodeling, again, with the help of Carl very much here. And so hypermodels are basically what we propose is that active inference requires a truly higher order hypermodel that tracks how each layer's precision weightings are being deployed system-wide. And so I'm going to spend a bit of time unpacking that now. But basically, hypermodeling forecasts precision deployment across the whole hierarchical stack, essentially enacting global preferences for precision. So the hypermodel actually, in a way, in the same way that you're trying to understand the causes of your senses, you take your precision field, the precision kind of stack, the whole hierarchical stack, as the hidden state that you're trying to understand. So the hypermodel actually starts to model the precision weighting across the hierarchical stack. And so now you get a model of models. So because the loop spans the whole hierarchy, the model ends up not only representing what the world probably is, but also how well it knows what the world probably is. This world model reflecting quality is epistemic depth. And this loop between the hypermodel and the first order stack of processing is the beautiful loop, right, that we presented earlier. And so in terms of what this adds to the standard model, so you have your multi-layer generative process as you normally do. And then what we do is add a global hypermodel to this. So this defines a generative process including hyperparameters, which modulate precision across the layers. And this is what enables the system-wide meta inference, supporting epistemic depth. And then we also can reduce hyper-free energy. And so this measures global prediction error incorporating all states and hyperparameters. So both what the hypermodel is trying to do and the first order stack, and minimizing this tunes the entire hierarchy, enabling recursive sharing of the reality model central to epistemic depth. And so this allows this kind of recursive refinement of a global reality model. And just like one more intuition building figure here is kind of a smart glass process where, excuse me, where the first order stack of processing, which is building the world model, is under normal circumstances transparent, right? In the sense that like a glass that you're looking through, you don't see the glass, you don't see your models. The models are being built. It's like what's allowing you to drive without being aware that you're driving, or ride a bicycle if you don't drive. But this transparency is when you're basically adaptively unconscious, you could say. And what we're saying is this hypermodel, by modeling the precisions across the hierarchy, allows you to know what you know. And so this allows you to transition the transparency of the stack into an opaque stack that is now seen, like seeing the window that you were before just looking through. And most of the time, most of our inferences, we just look through. It's what allows us to, deal with this like complex stream of information. And it's only small, tiny bits, of course, that we're actually aware of. And hypermodeling may be the way that this stack becomes aware, so to speak. And so it's a bit like if you imagine the hierarchy is building a model of the world. In a way, the hypermodel plays the role of like a conductor that's kind of tuning and it kind of brings this unity to the overall picture, to the overall orchestra, to create a kind of coherent symphony in a circular feedback kind of way. So the loop is between the conductor and the whole orchestra. So the hyperparameter is the conductor's master dial that tells every instrument how confident it should be in the notes it is playing. It hands out these confidence levels to every layer in the hierarchy based on global context. Awareness emerges when the hypermodel conducts the whole predictive orchestra, recursively tuning precisions until every part both shapes and is shaped by the music of the whole. So I think with the idea that potentially with something like hypermodeling and epistemic depth, active inference can also satisfy criteria 3 and therefore potentially provide a theory of consciousness, at least to the same extent as existing theories of consciousness, let's say. And they all have troubles because consciousness is a slippery, very slippery thing. So how might something like a hypermodel or epistemic depth be instantiated in the brain? I think this is really tricky. In fact, we tried to avoid this altogether, but reviewers forced us to come up with something. And so I'm really open to many ideas about what might be, how this might be instantiated in the brain. But obviously, one thing that the brain already does, as I said, has this unimodal processing hubs, and then the long range connections that allow for higher order processing, but also just the integrative processing. So, okay, there's already some things in the brain that allow for this kind of global processing of information, which we can draw on. But we also want to propose something else. So how can something like a global precision field be modulated? Or another way of putting this in terms of what we're trying to do here, what could enact global recursive control of the whole stack? I think including the kind of unimodal processing features, right? And so for that, we propose a dual channel broadcast for the hyperparameter or the precision field. And the first channel is neuromodulatory sprays, and the other is phaptic electric fields. So I'll present those. Can I just get a quick time check? I can't actually see the time on my computer.
Sure. You have about 15 more minutes.
Ah, perfect.
And you can extend that to 25 if you want to go over the 40 minutes.
All right. I went right. Yes, good. Thank you. So neuromodulation has a rich history. It's not an area that I'm an expert on, but there's a few things about it that makes me think that it's a potential channel for this kind of broadcast. And what we mean by sprays is this sense of this sense that it's spraying throughout the whole brain and tuning it. So sprays are brief diffuse bursts of noradrenaline, acetylcholine, serotonin, and dopamine that can shift synaptic gain over hundreds of milliseconds, embedding slow contextual information such as arousal, valence, and uncertainty. These are arguments many people are making, and there's, I think, a lot of evidence for this basic picture. Neuromodulation is the brain's way, you could say, of changing its own weighting rules. Rather than transmitting specific content, neuromodulators set the general tone, alter the rules of excitability, and enable flexibility and context dependence in neural computation. In fact, neuromodulation can also kind of modulate the way the networks themselves are kind of organized. So it's both changing the gain and the organization of the network. So there's really global processes it can shift over not very fast, but reasonably fast time spans. Or in Parr and Fristen's words, all three neuromodulator systems play the same computational role, namely an encoding of precision. Furthermore, all three neurotransmitter systems have the same basic effects on synaptic transmission, namely a neuromodulatory gain control. So, for something to control globally precision, this seems like we might be on the right track here. And so the second channel that we think is important is phaptic electric fields. Phaptic comes from the Greek word to touch, and so it's the electric fields generated by synapses, and so they're like touching throughout the brain, right? And so you're getting these relationships between all of these little electric fields produced by neurons throughout the brain, and this leads to all kinds of interesting emergence of all sorts of interesting patterns of electrical activity. And so There's much work on this happened in the last decade or so around checking whether these electric fields are just emergent phenomena or are they, in fact, do they have downward causality? And it turns out that they do have causal effects on the brain. So when many neurons fire together, they generate a local field potential. The resulting extracellular electric field can push neighboring neurons a little closer to or further from their firing threshold. This adaptive coupling helps synchronize assemblies of neurons. And this is, of course, what we measure when we're doing things like EEG, right? And MEG for magnetic fields. These experiments, so this is now referring to the paper here by Froelich and McCormick, show that the weak electric fields generated during normal neocortical activity have the potent potential to form a feedback loop that modulates the very activity that generates them. So you get this loop where they generate the electric fields, but these electric fields also affect the firing of the neurons themselves. And this is the crucial bit, macroscopic electric activity may thus represent a dynamic feedback mechanism that could serve as a network-wide synchronization signal that enhances the spatiotemporal structure of network activity. This is cool, and this is what then starts to look something like the kind of top-down causal influence that something like a unified reality model could have on the rest of the system in this sort of recursive, loopy way. So when you put this together, so working in tandem, the sprays may set the baseline temperature of belief, so broad stroke changes in gain or confidence over longer periods of time, while the fields impose rapid fine-grained tuning, so dimming the gain on a specific granular feature. So for example, dimming the gain on a specific, together broadcasting an updated field to every layer in time for the next perception action step. So the best we can, I think, come up with at this point is this dual channel broadcast, both neuromodulatory sprays and electric fields for something like hypermodeling. And this again may allow this beautiful loop to play out. So we've got some idea now of how we might be able to build a self-aware world, but just for the fun of it, I suppose, let's consider how this might look in large language models, since this is all the kind of excitement is here at the moment. So epistemic depth allows us to not only know our world model, but to know the gaps and to agentically and perhaps consciously seek a better world model in the future. It allows us to, you could say, know what we don't know. And this allows us to actually pursue out of curiosity to fulfill those gaps, not in some sort of like impulsive way, but in like a very aware way, in the way that I can explain to you where this gap in my knowledge is, and then to pursue the fulfillment of that gap. Hypermodeling allows the system to objectify or pacify and introspect about their own knowledge. And again, hypermodeling is just one way to instantiate this, I think, and may not be the end goal here, or may not be the final version of this. Epistemic depth therefore looks a lot like self-supervision, right? And this is a central issue in AI right now, is that AIs need to be reinforced by humans, and they don't have this capacity to basically just find their own way to better knowledge. They need to be supervised, whereas humans, we have this extraordinary capacity to self-supervise, and I think part of that could be this idea of epistemic depth. And so this is a paper from mainstream large language model research that just came out about 2025 in 2025, so really a couple of months ago, that I think is like somewhat in the direction of what we're getting at with epistemic depth. So in this paper, Learning to Reason Without External Rewards, instead of depending on external evaluation, this system uses the model's own assessment of its outputs or reasoning process as feedback. And specifically, this intuitor model is trained on its own self-certainty, its own confidence. So basically what it does is that it makes an output. So the model produces some output, then it checks its own confidence about that output and then rewards when it gets more confident. And so then you can kind of do gradient descent on confidence essentially, right? Like, so it outputs stuff, it checks its confidence on it, and then it just goes in the direction of more confidence. And this turns out to work really well. So it assesses its own output based on confidence and then maximizes confidence. This allows it to improve on math and to perform really well compared to other kind of common models that are based on standard kind of reinforcement learning schemes. And with decent generalization to coding as well. So it's I think like this is a promising way to think about the same sort of thing we're talking about, right? Of monitoring your own precision as a way to know what you know and to self-supervise. But there's a difference, of course, with what we're saying in terms of hypermodeling. And the difference is this: current instantiations of confidence monitoring are external rather than internal. The model completes a sequence, computes a confidence score, and uses that number outside the conversation to adjust its weights during training. But the hypermodel is all internal, right? So to extend these prototypes into a true hypermodel, the precision confidence predictor must move inside the recurrent loop, issuing a forecast of the confidence profile before the next token or action is sampled, guiding decision-making on the fly. So to do hypermodeling, you would need to, we're checking our own world model internally. We don't need to output something to know our world model and what we know and to our confidence. We know our own confidence on the fly. And so this is the kind of loop, the sort of extension that would be needed to do epistemic depth in the way humans do it. And I think this is cool and promising. This would put the loop inside even a kind of LLM system. And my background is in cognitive neuroscience, so I don't have the expertise to build something like this. But if you do, either please go ahead or let me know, and I'd love to come along on the journey for that. And meditation and altered states is a big interest for us. And you need to pay attention to this, I think, in any theory of consciousness, because this is the spectrum. This is the spectrum of consciousness, and if you're not explaining the spectrum, you don't really have a theory of consciousness. And so if you're interested in this part of it, and we can come back to this figure also in question time if you'd like, we go into how this theory helps us understand various different states of meditation in terms of abstraction, precision, and epistemic depth. And we also connect it to all the other theories. This could take forever to do in a talk, but there's of course many similarities to global neuronal workspace, a little bit like the reality model. Integrated information theory has this component of like, again, how it all comes together coherently. And recurrent processing theory, there's in hypermodeling a little bit of this kind of re-representation, also as in higher order thought theory. So there's, of course, there's much overlap. I think one of the promising things, of course, is that active inference gives us this formal way of working with it. So consciousness remains a pretty big problem, but hopefully this gets us it just gives us another way to think about it. This sense of being able to rediscover our own reality model in this sort of recursive way, and at least trying to model something like this, I think, is valuable. And really, I think what's new is this idea of, okay, yes, there's building the reality model, but obviously we have this capacity to be aware of it, and I think this is really something important to figure out. So let's just review the basic thesis, and then we'll finish. A system that is conscious satisfies three criteria: a world model, inferential competition, and epistemic depth. Together they form a beautiful world, a loop, a world model that knows itself. This beautiful loop enables the epistemic agency, global flexibility, and self-awareness reminiscent of self-supervised general intelligence. Active inference with hypermodeling could satisfy the criteria for a theory of consciousness, and curious to hear if you agree or alternatives. Thanks for listening.
Thank you, Ruben, for this wonderful presentation. Now I invite each and every one of us to unmute and turn their cameras on and give you a warm round of applause. That was
Thank you.
and intellectually invigorating. Yes. So now we open the session for Q&A and any questions from the audience. Let me try and see better the in case all right. So now I can see each and every one of you. Please raise your hand or just unmute and I'll be able to see. And while everyone is gathering their thoughts, I may venture a first question. Oh, no, Andreas, please go ahead.
Yes, I congratulate you and your colleagues on this wonderful talk. It's really brings things together. It's wonderful how you connect it with different theories, and you've really thought a lot through. So I really congratulate you. And I saw a video that you gave about meditation in 4 minutes. You explained it all for somebody like me. But you distinguish the narrating mind, the experiencing mind, and the witnessing mind, and also pure awareness. And so when I listen to you, they align with what you're saying to me, that for me, the world model is the narrating mind, and the inferential competition is the experiencing mind, and the epistemic depth is the witnessing mind. And when I think, and so I've collected hundreds of examples of basically three minds where you have an answering mind that knows the answers unconsciously. So that would be like the experiencing mind or this inferential competition. A mind that does not know, but asks consciously questions. And that's what I think of this world model as being all about. It's really a bunch of variables and slots that are waiting to be filled. So that'd be the narrating mind, this chatter, this verbal chatter, let's say. But the crucial thing is that there's this third mind that may be related to your conductor, but that kind of recognizes the difference between, oh, is this the mind that knows or is this the mind that doesn't know? That's the epistemic depth. So I really support everything you say, but one thing I would think, a couple of things I would think is that the world model itself, because it distinguishes the self in the organism, it kind of knows that boundary, very well. It's a very crucial boundary. I think the crucial thing in the epistemic depth is not just that you know yourself, but you know what you know and you know what you don't know. So whether it's Confucius or Jesus, like they really had sayings like that, to know what you know and to know what you don't know, and of course, like to know the difference. That is, I think, for the investigatory mind, the mind that matches together. And so instead of maybe consciousness so much, I think it's absolutely important that you're looking at the science of inner human experience. But consciousness is rather passive sometimes, but like cognizance, deliberateness, willfulness, on your scale of luminosity when you're absolutely, clear. I think that's maybe something to think about. But so I just want to congratulate you and thank you for, and maybe just to conclude, that you brought together insights from meditation and the formalisms and the frameworks of active inference is a very huge accomplishment, and then that'll connect further. So I'm very excited for you. Thank you.
Thanks. I really appreciate that and the positive feedback and everything. So I just want to clarify like a few things. I now have, it seems I have closed my slides, but wait, have I? No, I found them. Good. I wanted to share it just to clarify, just in case that this is something that wasn't clear for others. So if we go to this slide, in everything in here is what we're aware of. We're not aware of the inferential competition. The inferential competition is the process of like combining our priors and the input to generate the posteriors. What we're aware of is here, and so you'll notice that even those like very basic sensations are part of this reality model. And so this includes even the subject-object duality, right? Like we can be aware of our subject-object duality, and everything else within this in this reality model. So it's not just that the world model is your narratives. The narratives are a small part up here, as you can see in this cloud, this wonderful cloud that Shamil created, of a narrative self, but also our minimal self is here. Our sense of our body is part of our reality model. We're aware of it or we're not. And it's epistemic depth that we're claiming allows you to be aware of your minimal, your pure awareness, your embodied self, your narrative self, and so on, because it's what allows you to see the whole stack. right? And this has been the mystery of meditation, is that you can somehow become more and more aware of the whole stack. And the question is, how is that possible? I think epistemic depth is this candidate here. But just to say that the reality model includes all of these other things that are part of this process of emergence. Yeah. Thank you. Yeah. And Shamil and Carl, feel free to jump in if you want to clarify anything for any of these questions. Yeah.
Thank you, Andrews. Any other question? So in the meantime, let me try if I see if I understand this. So word modeling, computational inference, and epistemic depth via hypermodeling are the three necessary and jointly sufficient conditions for something to be phenomenally conscious. Is that correct?
Yeah, that could be true. That's at least that's our claim.
That's the claim. Okay, so that's the claim. All right. So that means whenever you satisfy those three conditions jointly, so the set of all those three conditions is instantiated in a system, some form of experience is present. Because the theory, as far as I could gather so far, is just a theory about the presence of consciousness, at least in the way you presented it, though the insinuation and gesticulation towards the meditation and other forms of phenomenal character suggests to me that you want to expand this into a theory of also the character or quality of experience. So it will be a full-blown theory of consciousness. Am I on the right track?
Yeah, yeah, and then but the beauty is that you get a lot of that for free through active inference, right?
Mm-hmm.
So because we have so many people working on detailed models of how the kind of different character of conscious experience, and we also have like papers on meditation and psychedelics and all of this kind of stuff. Active inference already has like a lot happening in that space, but what it just didn't have, I suppose, is this quality of how it knows that it knows. And this is the part that we try to add there. And in some way, I think the other part of it, what makes it a truly global, and this is not our theory, this is active inference, is that it does all of that other stuff in a way already. And so as soon as you get epistemic depth, I think you start to have something that looks like a more full-blown theory already within active inference. Yeah.
I see. Okay. But still, the fact that you add epistemic depth and the idea of a hypermodel, and furthermore the further construct of hyper free energy, this is the new thing that you bring, and this is what makes or breaks, in as far as I could see from your presentation.
Yeah.
That is absent. That's the third condition, and should it be absent, you are a machine without any ghost in it, or a philosophical zombie.
Yeah, right? That's what plays out when you think about it through this way. I think indeed. Yeah. So if you don't have some sort of way to recursively know what you know, then it's just like it's just like us driving and not knowing, right? Where we do so many things unconsciously, right? So there is some sort of first order process that just doesn't make it into consciousness. And we think that indeed, and so we are ourselves zombies a lot of the time, right? A lot of what we do is in this sort of zombie mode, and we're just saying the first order stack is this zombie mode, and then the hyper stack in this beautiful loop is what turns zombie mode into aware mode, maybe.
So then by inference, your theory is quite discriminative in nature, in the sense of that it distinguishes between conscious and non-conscious system with a very high threshold, because not many systems in nature will instantiate your third property, right? So I will venture and say nothing except brains in biology, or I don't know, maybe there could be some hypermodeling in the pancreas or or in another part of the body, or in cities if you want to venture outside biology. I am not sure, or even in economies, or like state centralization in a government. I am not sure what's the mechanism here. So what's the precision controlling mechanism that will be instantiated in different architectures? But as far as I could tell, your emphasis on the brain only. And moreover, on brains that are quite sophisticated and capable of this advanced recursive abstraction, precision-weighted abstraction, which is the duo in the third condition, makes humans likely only conscious, or maybe higher apes, or something like that. I'm not sure about birds, whether you think their pallium is sufficient for that. Cephalopods, fish.
No, really, I'm glad this comes up so that we can talk about it. We in the paper we have a section actually called hypermodels and tiny creatures, and the reason for tiny creatures is that, you know, I think in principle something like a hypermodel could be instantiated in very, very simple systems, because the complexity of the world model is just very simple, right? So it's the world, building a complex hierarchical world model with thoughts and everything. That's what requires like a lot of computational energy. But like simply knowing like a very simple world only requires a small sort of another parameter that just tracks the confidence in that very simple thing that you know, and now you have like already this loop. So we even in the paper, I think I just pulled it up, like we point to so in nature, many single-cell organisms already show protoforms of self-measurement of intracellular states, but whether that amounts to a reflective awareness is debatable. One could argue that very small multicellular creatures or tiny insects, and we list a few, start to approach the complexity needed to implement the minimal hypermodel. These small but highly integrated nervous systems can tune sensory signals, modulate action policies, and reconfigure local loops via neuromodulators, suggesting partial analogs of top-down reweighting. Whether these are enough for a globally coherent, knowing that they know remains unknown, but they are prime targets for studying borderline cases of reflective multi-level organization. So I think just the basic idea here is that most of the energy is actually in building a complex world model with thoughts, but most things don't do that. You can have a very simple world model and know it in this recursive way. And I think that I imagine very simple creatures actually embodying hypermodels.
Okay, so now I understand better, except that in these simple creatures, there won't be the same broadcasting mechanism that you highlighted, the dual channel mechanism, right? With ephaptic field coherence and with the neuromodulatory sprays.
I think in some simple I mean, I don't actually
Depending on obviously the creature, yeah.
Yeah, I don't know where that line is drawn with creatures, because again, in general, I think it's an algorithmic theory in a way, and so it's just like that can be instantiated differently in an LLM. It could be instantiated differently in an active inference agent. It could be instantiated differently in and Mosquito, right? But I think, well, Mosquito is an example where I think it would be similar, because I think there you still find neuromodulators and you find neurons and you find ephaptic fields and so on. So in theory, it could be there. Yeah.
Okay. So there is a question in the chat from David Highland. In case, David, you want to unmute yourself and ask the question, you're more than welcome. If not, I will read the question to everyone. So the first observation is that your theory, this sounds resonant with attention schema theory by Michael Graziano, and there's a link. And then the question is, a primitive form of this loop could be instantiated in markets through the price mechanism. Market participants collectively influence prices through their trading activities and then adjust their trading activities according to the emergent prices that they observe. So is the market in some way conscious, Ruben?
I'll just read that one more time. Markets participants collectively influence prices through their trading activities and then adjust their trading activities according to the emergent prices that they observe. Well, I don't really see like binding a coherent reality model here. Obviously, you do get this kind of like emergent properties that are somewhat global in nature, but I don't see how all of those come together into this like higher order world or reality model that is then sort of monitored. In fact, I would say in some sense, it's the humans who are monitoring the global part of it, right? It's the humans that bring the kind of global order to it through our capacities for something like hypermodeling. But it's really interesting to think about this, to try to imagine totally different kinds of systems than ours as instantiating these things. Like, does a forest do this, for example? Maybe, I'm not sure. Yeah, it's fun to think about.
Definitely. So Andrews, thank you, David, for the question. Andrews has a different question.
Yeah, and I like the thinking about the tiny creatures, you know, And so to go to your main question, like the reason for experience, I think of a quote by Carl in a video I saw. Basically, he said that there's precision afforded to sensory experience and versus precision afforded to all the accumulated knowledge of prior beliefs and narrative. And that the right control of the balance is basically the basis for mental health and for creativity. And see, so what that suggests is that these are not just local things, but that there's some kind of global choices to be made, like that you can. And so I feel that very starkly in my mind, like I can go with my intuitive, non-cognitive performance, or on my lucky day, or on my unlucky day, I'm going to say, no, think rationally, break it down, use your model. So I feel access to some kind of conceptual model, and I also feel access to things that don't seem coming from the model, but seem to be binding, seem to be experiencing. Like that experiencing mind and the narrative mind. I feel that very strongly, and I think you do. So in terms of internal evidence, but the idea I can see, you see, that is it my lucky day or unlucky day? Every tiny organism wants to know. You see, in the Babylonian dream interpretations, they want to know, did you dream the left hand or the right hand? Like, is it my lucky day, go, or is it unlucky, like, be careful? Or like, can I deal with the environmental tension and just optimize that? Or do I have to create artificial tension and say, no, you don't want to drive off the cliff, pay attention to the road signs, right? So there's these two modes, and they're global modes. They're not, and so the idea of the global synchronization to say, okay, you have a 300 milliseconds where it's pre-conscious, then you have conscious response. But I've heard that there's a delay. You see, and I think that could be the purpose of the synchronization is to delay, not to rush to model too early. There's a third mind, or this epistemic depth is saying, hey, maybe I want to let things settle down. And that's something that can be globally synchronized to slow everything down in the brain from making the decisions too quickly.
I think very heuristically, you can think about epistemic depth as being the sort of third part of the system that is able to be aware of the narrative self and the experiencing self, and yet is neither of those things. Very, very heuristically, I would something like that. That's the only. I don't really have much more to add to that.
Interested.
There's a question in there you can
add the idea. See, then it becomes clear why we have two hemispheres. If this is not about implementation, about user requirements, the significance of this dialogue, why do octopuses have two hemispheres? Why do we have an adaptive immune system and a innate immune system? All these types of choices, dialectical, they're there, and so it's maybe in the thalamus and the basal ganglia that's actually where the conductor would sit. Those are just stages, these hemispheres. They're just enrichments and etc. That's not where, consciousness is very meager, I would think. It doesn't require much. It just requires that little tipping point.
Okay, thank you.
Thank you, Andreas. Are there any other questions from the audience? Okay, Stephen Rood has one. Go on, Stephen.
Thank you. Thank you to all of you for addressing this issue, and Ruben and Shamil for your really wonderful putting together of so many aspects of this issue. I want to try to give words to three areas of thought here. One is I sympathize with your interaction with the reviewers and their insistence that you make application to the brain. I actually would ask the same thing. I don't think we'll really understand the proper application of this, I think, fantastic framework, mathematical framework, unless we look at the biology. There are so many complex systems, not just the local field potentials, but also the influence of genetic expression at the synaptic level, or the widespread coordinated genetic expression that affects synaptic activity. As one example, the hormonal effects, the endocrine effects conveyed by the vasculature to the neural systems that have the same sort of modulating effects. And have intrinsic control with the pre-capillary bed muscles affecting how much blood flows to the area of requirement. These can also be represented in this mathematical framework. It doesn't have to be a dual channel. It's a multiple channel consortium of effects. And I really think they need to be considered as well as the interpersonal effects, not just individual, but interactions of the individual with the environment, sort of inactive effects, which also I don't believe can be separated. We think of meditative effects as being just within, which is true, but enacting those effects requires a sociological conceptualization. But really, even if you take a Buddhist perspective, the Buddha was not concerned with any question that couldn't be answered. The only answer possible was within oneself, because sort of taking a Hume approach or a Kantian approach, all we can possibly know is what we can possibly know, based on our construction and our behavior. This is the second point. We're always going to judge consciousness by our own conception of consciousness. So, of course, we're only going to judge things as conscious if it fits our personal conception of consciousness. This is still something that's addressable by the mathematical framework, but we may not know. We may not be able to properly assess for ourselves. I don't think it's really necessary to apply the active inference framework to the biology necessarily. I think once one hears something that makes perfect sense, one thinks, well, it's obvious. The trick is coming up with the principle in the first place, and I think hypermodeling is that crucial step to represent this evaluation of world models. And once again, we're only going to consider the world as what we think of as the world, when obviously the universe is the world, and our consciousness doesn't comprehend the universe, only our conception of the universe. I just want to compliment you, congratulate you, but insist that really for us humans, we want to know how we understand consciousness, which means understanding the brain. And active inference is a very useful, I'm thinking perhaps necessary tool, since it has the mathematical framework to build the appropriate models, which, again, that's the essence of it, isn't it? Finding the appropriate implementation of this framework, accounting for all of the relevant components, which are going to have to be the components that are there, which includes the vasculature, the history represented in the genetic expression, and experiential development over time, and the interaction with the environment, because no human exists independently, obviously. So those are my comments. Thank you so very much.
This is great, Stephen. There's a lot of wisdom in what you say, and I actually agree with everything. And there's like endless unknowns, and I am operating under very sort of naive assumptions about what consciousness is, and then trying to give a model of my own naive assumptions of consciousness, which are always evolving, right? So I expect this to be an evolving process, and And it's the reason we were also struggling with this idea of how this might be instantiated biologically is indeed because there's an exceptional amount of things that are not under our steady control, like in a computational model. And there's so many factors that are difficult to even imagine how they all kind of combine, right? And when we're building like a computational model trying to do AI, you're massively simplifying. Like, even if you think about even epiptic fields are not really instantiated in any of the AI systems that are out there right now. So already that's something that isn't really even a thing. And then not to mention, like, as you said, the hormonal system and all of the other things that are going on in the body, which is just like a confluence of diverse systems. And also, again, just to mirror the same point you're making, this fact of like being porously connected to a world and enacting at different kinds of niches and so on, I think this is central. I think this is kind of built in from the ground up in the whole active inference approach. So I think this is nice. I think this is important to understand that this sort of like codependent relationship, I suppose, between the world and the organism is right at the heart of active inference and is actually what makes it, I think, so beautiful. Yeah.
Yes, I like this phrase. We're blind to what we're blind to, which is, I think, one of the reasons there has to be an external dialogue always. There can't be this was the other point. There can't only be internal representations.
No, I think that's why, if you remember, sorry to interrupt, but if you remember the camel image, that's exactly, it's hallucinating a camel. If you're only high precision on the priors and not in the dance of the input, and the dance of the input being also the world and other people, then you're off in your dream, right? And it's only in this sort of tight relationship with the present that there can be this kind of optimal inferential process. Otherwise, you can get hallucinations and mental health issues and so on. I think this is exactly right. Yeah.
I may have misunderstood, but doesn't there have to be, doesn't the hypermodel have to include this external dialogue?
The reality model is constructed with this dialogue very much at the heart of it, right? So in that sense, yes, because epistemic depth is the knowing of the outcomes of this dance, right, between your priors and the input. So in that sense, yes, the relationship is already there in the very construction of the world model. Yeah.
Thank you, Stephen. So if there are no other questions, I will maybe venture one last question. And then I promise the barrage stops, Ruben. Though I suspect you enjoy it, right? At least I enjoy it a lot. But I'm not the one interviewed, so to speak. So maybe this is the question I'm going to ask now. It's not necessarily addressable to you given your expertise, but also maybe addressable to Carl or Shamil. And I will target that a bit sensitive point of the brain implementation of the dual channel hypermodeling, or like epistemic depth construct. So the point is here that neuromodulatory sprays, I mean, depending on what's your definition of neuromodulatory, we are talking at a time scale of 100 to 1,000 milliseconds. But if you go to fast ionotropic glutamatergic signaling in the AMPA receptors, that's a couple milliseconds. So depending on, okay, what's the neuromodulatory meaning here, whether you distinguish between neurotransmitters or neuromodulators, it's a bit vague, the distinction here in the field. And then you have the coherence of the epiptic fields, which is in the time scale of 1 to 10 milliseconds, or it's very short-lived. So that coherence is short-lived. Moreover, since you have a hierarchical implementation, those fields decay quite rapidly with cortical depth. So that adds a bit of insult to the injury of this scale misalignment between the neuromodulatory sprays and the epiptic field coherence. Though I know in your mechanism, as far as I could follow from the half-minute presentation of that slide, you have different roles for that. So one is for the fast local management of precision, and that's where the epiptic field coherence goes on. And then the neuromodulatory spray sets the, if I'm not wrong, the baseline or a sort of tone for the entire precision weighting in the hypermodel. So that's how you balance these two timescales. One is fast intervention. One is more baseline setting of a tone in this sense. So then we see that there are these biophysical differences between these two mechanisms, quite significant biophysical differences. So my concern is here that these differences do not dovetail well with this construct of a broadcasting mechanism that is precision preserving and almost phase aligned, given that the epiptic fields are very heterogeneous in phases. So it seems that the story needs a bit more flashing, but it's probably also my ignorance of how to see this fully fleshed out, and that's why I asked this question. And yeah, Shamil, please go ahead.
No, Ruben, do you want to take a stab at that?
I think you actually painted the picture very accurately. So I just want to say that first of all, I think that your base assumptions about what we're trying to say is right. But I just want to, and then I'll let Shamil, just the sense that I think how these things are instantiated in living organisms are going to be much more messy and not only dual channel but multi-channel than they would be in a clean system, right? So whenever we're saying even something like hypermodeling, we're oversimplifying something that actually there's a ton of computations going on, right? And then we're saying, okay, how could something like that simplification be instantiated? And then, okay, it gets very messy. That's all I want to add to that. But you're totally right, actually. And Shamil, over to you.
Yeah. So actually, we in fact had this discussion, and interestingly, I think in the paper we make it very clear that we're actually not proposing that neuromodulators and electromagnetic fields are the only kind of global mechanisms. In fact, I think, I'm not quite sure, but I think the word dual channel was dropped in the final paper. It's kind of, novel channels. And the reason is, as Ruben sort of explained, that the underlying hierarchical, generative model, however it's instantiated neuronally, is itself generating this recursion. So one of the key things is that the signature of epistemic depth and hypermodeling is recursion. And of course, it's no coincidence that the signature of global workspace theory is also recursion. The signature of IIT, in fact, is recursion. It's kind of a complex entangling of causal information, cause-effect information, to create kind of an emergent system, exactly like the global broadcast creates kind of an emergent system where everyone knows what's being broadcast and it's shared widely in the brain. Obviously, recurrent processing is almost by definition this kind of recursive process, and higher order theory also has this. So recursion. The question is, how is recursivity being how is it being informationally implemented in the brain? And neuromodulators is one, and electromagnetic fields, but fundamentally emergent properties of neural networks, widespread networks, that we might expect from conventional neural connectivity and neural networks. And I really loved what Stephen had to say about this. There's all sorts of other mechanisms like, strange ones like, blood flow, vascular systems. And even the point is that recursion through the action perception loop, as Stephen was also suggesting, is a kind of recursion. So hypermodel may be implemented on a whole series of recursions. And this is the thing, that hypermodeling is kind of, in a sense, silent about the actual physical instantiation or the implementation. But all of these things actually might be involved, including conventional feedback synaptic control.
All right. Yeah, that's definitely illuminating. So maybe Shamil or like Carl, could you say a few words also about how the hypermodel updates? Because that I try to remember the equation, but yeah, I remember the neuromodulatory thing, but the equations were a bit. Maybe Ruben, can you show the equation?
Yeah,
I mean,
Ruben, there's a slide that you had with the
was it two?
Yeah, I can pull it up. Let me see. Sorry, my slides tend to.
This comes to mind as, all right, any model tries to maintain within bounds the precision of its priors to converge on certain posteriors. So if this is the overarching model, what makes this model change so it doesn't freeze into?
So then the next one, I think, the next slide, yeah.
Yeah, this one, yeah, exactly. Those two equations on the right and also on the left.
So I think the idea is that on the left-hand side we have essentially the underlying hierarchical generative model. But what happens is that you get belief updating, which updates the hyperparameters, these phi parameters, throughout. So that gets fed up into the global hypermodel, and the global hypermodel is then like I'll use the word, just spraying the phis back into the hierarchy. And so obviously it's doing it all simultaneously, but it's presented like a two-stage process, but actually, of course, it's happening all together, all in one global maximization and minimization.
And just to put some conceptually, like how I've made sense of this, and yeah, Carl, jump in and say that I'm being stupid if I am. But basically, the idea is that just like you're trying to infer the hidden causes of your sensations and you're paying attention to prediction errors, the global hypermodel is doing the same, except for your precision distribution. I mean, the kind of field of precision weights across the stack. And so you make errors and then you update based on those errors when you try to forecast your precision and in the present moment, but also in the future moments. And so it just becomes another variable to be explained, right? And over time, that hypermodel gets better and better at explaining those by reducing hyperfree energy.
Okay. That's I think enough for this Q&A session. And with this being said, I suspect it's Carl's turn now. No, I might be wrong. My precision is not that high now.
You're not sure whether it's my turn.
Now that you showed yourself, I'm sure my precision went up.
Ah, good.
But you're aware that you're not sure.
I was aware I'm not sure. So this is my proof that I'm an experiential agent.
You're not a tiny creature.
I'm not a tiny creature. Well, it depends. There's a scale.
Excellent. So yeah, you should be again congratulated on a wonderful presentation and equally enjoyable exchange with everybody in the Q&A session. And I can't help notice, Ruben, have you got a cold or hay fever? You seem to be remarkably on the ball if you have got a cold.
I have I don't really I think it's postnasal drip. I have like very strong allergies to dust and dust mite.
Oh, I see. It's more
And
like hay
and
fever.
this yeah, hay fever gives me a cough then. Like I clear my nose with medicine, but I can't seem to clear my throat. And so this is always terrible for giving talks, especially in the afternoon for some reason.
Okay, right. Um, and also, there were wonderful graphics. Did all those graphics get into the smart screen one? Did that get into the paper? Oh,
Yeah.
good. Right. So I forgot about that. But the one with the brains didn't. But I presume it was his two intuition guiding as opposed to informative. But
Right.
it'd be nice at some point if you sort of write your book to make sure all those graphics get in there because they are very helpful to to sort of
Oh, that's good.
organize people's thoughts. Anyway, summarizing, bringing together cross-cutting themes and pointing to uh, um, literatures which I suspect you know quite deeply. And indeed, so what I was doing when you were sort of mentioning key points and during the conversation, I was just picking up papers that I have been involved with in the past that speak to some of the key questions. I repeat, I suspect you know most of them, but there may be one or two that you didn't. And when you write your book, you can sort of say, and we can call upon this body of work or this idea or join these dots to substantiate a number of points. There's too much really for me to remember everything, but I hope that the papers I put up will remind me of sort of the key points. And I'm just going to focus really on some of the practical questions as opposed to the philosophical issues, which you're more expert than I am in. The practical questions that reviewers or interested correspondents would likely post to you, and ways in which I think you could counter in a fairly straightforward way. So, as an example, I'm going to use the last exchange and then move on to what I see as something which could be emphasized in terms of knowing what you know that would address some of the other questions you've got. But just coming to the sort of the biophysics of the process theories that would attend this this principle, and in particular the notion of epistemic depth. That you don't need to have a process theory, but if you're talking to a neurophysiologist or a neuropharmacologist, then it would be very useful to have a process theory, because that would give the empiricist a handle on what you would predict, what they'd be looking for experimentally. And I think there are two roads to that last question about what do you mean by neuromodulation. I think that there are sort of there are two ways in which you can answer that very, very precisely. The first is that neuromodulation is meant to describe the electrochemistry, the neurochemistry of something that changes the conductance, but not depolarization. So things like glutamate that Robert was talking about, they depolarize. But there are a whole other set of neurotransmitter mechanisms that do not depolarize, but they change the conductance of the cell membrane, thereby rendering it more or less sensitive to the depolarizing effect of driving synaptic transmission. So neuromodulation has a very particular meaning. It's not any kind of transmission, be it ephaptic or be it sort of via classical synaptic vesicle release. It's that which contextualizes the responses to depolarizing effects. And those depolarizing effects can be, I repeat, mediated by neurotransmitters, but they can also be mediated by the local field potential has been mentioned. And when that becomes sufficiently coherent in space, that can be ephaptic, in exactly the sense that you meant, that second route to a neuromodulatory effect. So I think you can make that very clear, which basically puts a lot of neurotransmitters in one group as opposed to another group. So all the classical neuromodulated transmitter systems of the kind that psychoactive drugs work on are all neuromodulators, but these are not the neurotransmitters that keep your brain firing. This is, more simply sort of GABAergic and glutamatergic, and as has been noticed, they have very different time constants, and that takes you to the next level, which is that epistemic depth is necessarily a slower dynamic than the information transmission and the content of the beliefs that are being implicitly updated in a predictive processing or active inference sense. And I think that separation temporal scales is quite crucial. And it is also well understood and well defined. So neuromodulators will only exert their effects over a time course of about 250 milliseconds plus. And there are lots of mechanisms after hyperpolarization, intracellular calcium mechanisms that are engaged. All of these mechanisms have very slow time constants, akin to the cognitive moment, and longer. So when you bring in neuroendocrine or possibly sort of neurovascular aspects as well, then you introduce even longer and longer time constants. So the physiology of neuromodulators is very, very clear. They unfold more slowly than the content in which they contextualize. And of course, that's exactly what you would predict from a purely sort of philosophical point of view. If you want to know, in your words, how do you anticipate the precision or the confidence or what you don't know, these are contextual variables, attributes, that must outlive in time the content that they contextualize. And then you can move to a slightly more formal argument, and I'll do, just to sort of decorate these arguments. I'll grab the screen and share. Good. You can decorate these arguments with an appeal not to neurophysiology, but to the very structure of cause-effect structure in the physical world. So you can start from a number of different perspectives. The point you're trying to make is that this epistemic depth, by definition, and possibly emerges from or at a temporal scale that outlives the content that is known, and that really can't be any other way once you start to talk about the hierarchical world models, or models of a world that is quintessentially scale-free and has a hierarchical structure. As you become more abstract, take the X direction of one of your graphics, you necessarily slow down as you coarse grain. And the maths of this is something called the renormalization group. So in the renormalization group, what you have is a description of a scale invariant universe that has to be recapitulated in the world model or the universe model of that scale invariant universe. So your model will, by certainly under the free energy principle, will have to have this scale invariant aspect. If it's a network, you can call it scale free. And what that simply means is that there's a hierarchical coarse graining where the same kind of mechanics, the same kind of dynamics are recapitulated, but at coarser and coarser spatial and temporal scales. So as you move to the more abstract representations and you see the entire hierarchy, you see the entire depth, you are necessarily at a much slower timescale. It can't be any other way in virtue of the renormalization group. And I say that because the renormalization group is now finding its way into practical implementations of artificial intelligence and machine learning. And this is one of our recent articles that is in fact meant to be, its short title is Renormalizing Generative Models. And Max Tegmark has also written about, in a slightly more heuristic way, renormalizing generative models or renormalizing world models as a necessary attribute of any model that survives or in some kind of lived world. So the point here is you can appeal not only to physics, but also the physics of machine learning to say that the the structure of your world model must be describable in terms of the renormalization group, and therefore the highest level that prescribes that top-down part of the circular causality of epistemic depth must be must have a time scale that transcends everything that it's looking at. So it has to accumulate things over time, and that view fits very nicely with the view supplied by the physics of self-organization as described by synergetics and center manifold theory, where you'll find notions of circular causality articulated in many ways. And it also, I don't know if you know George Ellis, but he talks a lot about this in terms of bottom and top-down causation. I prefer Hermann Haken's formulation. It comes from laser physics, and it's slightly sort of more accessible and more and less less poetry and more maths. But the key thing about synergetics is exactly the same story, that in any system that has any system will have a macroscopic description, which is the result of a coarse graining operator, an RG operator that forms the renormalization group. And out of that emerges a number of things. I repeat, the center manifold theory can be seen as a mathematical version of this. The slaving principle is another principle that emerges from this. But from your point of view, the order parameter concept is quite central here, which is another way of expressing exactly the same aspect. So I'll just read this out. The order parameter concept is generalized by Haken to the enslaving, on the slaving principle, saying that the dynamics of fast relaxing stable modes, this will be the content of your belief updating all the way down to the sensorium, is completely determined by the slow dynamics of, as a rule, only a few order parameters. So there's this natural separation of temporal scales. So the epistemic depth has to be in and of itself slow to contextualize the fast variables. So again, you can sort of have a paragraph or a chapter celebrating that it couldn't be any other way. And of course, I repeat, you can induce the circular causality that underwrites the slaving principle and this like separation into fast and slow. Another way of motivating that, which brings us to the ephaptic aspects, is to note that the ephaptic dynamics you're talking about, which would be, if you like, the things that contextualize the postsynaptic sensitivity of the neuronal elements doing all the belief updating on the populations. When you're talking about ephaptic effects, you're talking about stuff that is averaged over space. So what I was saying previously is stuff that's averaged over time or has a slower time constant. But when you're doing these, applying this coarse graining or RG operators that constitute the renormalization group, you're also average over some state space, and literally it's a physical space when you're talking about sort of ephaptic effects and their synchronization, again, as was noted. And it's I put this up just out of nostalgia. It's David Chawla, who's now a cardiac surgeon in Texas and incredibly rich, was my first PhD student. Eric Luma was an interesting chap. He worked with Jerry Edelman and Giulio Tononi at the Neurosciences Institute at the inception of IIT. And we were all at that time fascinated with synchronization and emergent properties. But the point being made here is that the degree of synchronization of possibly ephaptic electric fields is governed by the mean activity level that is itself a product of the neuromodulation by the classical neuromodulators that set the context for the response to the driving belief updating. So there's a beautiful chain, physiological and physics chain, which reiterates your point that it's not just two separate mechanisms, it's everything that has this this sort of scale-free aspect that can be described on different levels that gets into the game to equip your world model or its inversion with this kind of contextuality and circular causality. And that brings me this notion of synchronization as being one, if you like, order parameter from the point of view of synergetics. That is the process that realizes or instantiates the spraying. So you've got, for example, a spraying, a literal spraying of the cortex and subcortex by the ascending classical neuromodulatory systems. They change the postsynaptic gain. That has, through circular causality, a higher scale effect on the local field potentials, and at the same time an increase in mean activity levels, because you've now enabled through these neuromodulatory effects responses to the afferents to all the neurons in a population, and then these things get synchronized, and that leads you now to be able to tell a story about where are we now? A story, forgive me, about communication through coherence. So if you wanted to, you could say that one way of looking at this coordination of message passing, and I would probably use contextualization of the message passing that inherits from the epistemic depth and the control of the global profile of precisions. One mechanism would certainly be a synchronization of ephaptic activity that is circularly coupled to the firing rates that induces a coherence, and that coherence now greases certain pathways and attenuates other pathways, and actually also does the selection that you were talking about. When you're just reading the mechanisms of selection purely in terms of fast, usually synchronous depolarization events, as you can measure with with electrophysiology, and of course that allows you now to say that this is exactly the same one aspect of the mechanisms that underwrite communication through coherence that has been proposed as a mechanism of attention. So you're now saying all of these things are just words for the same overall phenomena, that to control your precision in a global way is to control your attention in the right kind of way, to get the attentional set in place that contextualizes the message passing and the belief updating. And so Pascal Fries, this is sort of a rework of Wolf Singer's original work on fast gamma activity and its role in contextualizing the influence of one neural population on another neural population. So, in terms of making friends with the global neural workspace theory, this would be one electrophysiological manifestation of the mechanisms that actually underlie the ignition that is instantiated by the epistemic depth. So that would be him. Another little if you like, string to your bow, arrow, I don't know. Another perspective on this ephaptic aspect, one facet of many facets of neuromodulation, as you rightly point out, will be recent work by Earl K. Miller. And interestingly, Earl was a student of Bob Desimone at the same time that Pascal Fries was at NIMH, and then Earl subsequently went there, and as did Bob Desimone, went to the McGowan Institute in Boston, and then one of my early PhDs, postdocs, Dimitri, went to work with Earl, and this is fairly recent, I think. Oh no, it's a couple of years old. But they really pursued this ephaptic coupling aspect in terms of contextualizing your belief updating in the context of mnemonic-like functions, working memory functions. And subsequently, Earl himself has become a bit famous last year for really pushing this ephaptic large-scale effects of slow synchronous fluctuations of electrophysiological effects as coordinating message passing in the brain. I haven't read any great depth what it's been going on about, but you might want to just do a Google search on some of his more recent work, which just, as I say, lends some empirical and perhaps even sort of complementary theoretical support to the importance of it's not just dopamine, thank you, it's everything else that follows. And there are many ways of telling that story, but if you wanted one that emphasizes haptic coupling, then Earl would be your man of the moment, possibly not next year. Yeah, well, I just want to remove this. The reason I put this up there is that I've just gone through a manuscript written by Don Tucker and Fan Liu. I get co-opted just to check the technical details, and then they force me to be a co-author, which is very gracious of them. A little bit like you, I'm something of an admiring spectator on this work. This work really gets into the weeds in terms of the functional anatomy of neuromodulatory systems. So I'm just putting this here as an invitation to write to Don Tucker and say that you'd presented what the epistemic depth hypothesis and the beautiful loop hypothesis to the TMB meeting, and Professor Friston thought that you'll be very interested in his current draft that has just been submitted to Entropy, where they really drill down. It's not this paper. This paper was a prelude to the current paper. The current paper really gets into the weeds in terms of all the functional anatomy of the neuromodulatory systems, and how they might underwrite consciousness from their perspective. It's not so philosophically nuanced as yours, but it certainly tries to speak to that. But also it appeals to the use of these systems in the different stages of sleep, as a way of looking for empirical evidence that these are the things that set the scene in a very similar way to your proposal. These people are effective, although they work for Bell, the company, but they're effectively comparative physiologists and anatomists, so they have a really deep understanding of developmental neuroanatomy and how long these various sort of modulatory systems have been around and what they might have evolved for. So it's a fascinating read. It's very scholarly. If you can get your hands on the draft, I would recommend. I think you will enjoy it. You probably won't be able to use much of the material because it's too far outside philosophy, but it really does give you a lot of material that you could use to answer reviewers' questions. What are the actual biological mechanisms that underwrite these, or processes that underwrite or mediate epistemic depth as described? So Don Tucker is your person. Oh no, it's gone away. Never mind. I was just trying to, because this has been recorded, if I can get yeah, there you go. He'll have well, you'll have to find his email. Okay, that's that one. Jumping around a bit, perhaps. Well, going through this. What I'm emphasizing, which is what you already know, is that there is you can talk about epistemic depth as this global control of precision as a formal, in terms of inference and the formalization of belief updating. If you were a physiologist, you'd talk about it in terms of postsynaptic gain control in exactly the way that I've just been describing. If you're a psychologist, you can talk about this as attention, and the different kinds of attention you might have. And I think what you're talking about is the highest kind of endogenous attention, and you can almost call it self-attention. Endorse that by just noting that the machine learning community have now just realized in the past few years that attention is all you need. So Shamil will know this, but I'm not sure that Ruben will. But the thing that makes large language models work is the transformer architecture. The thing that defines a transformer architecture are the attention heads. What the attention heads do is the neuromodulation. So there's a reason, and I'm sure that they didn't fully appreciate why, but there's a reason why attention has got its name as it has, because it does attentional selection. So it doesn't determine the content, it selects the content, it contextualizes which content is subject to subsequent processing in exactly the way that you're describing. So I just thought it'd be nice and cheeky to notice that the ML have also discovered the importance of this kind of contextualization, and they call it attention, and hence attention heads, attention heads in transformer architectures. This would be the equivalent in the active inference sphere. This was a paper written, I think, by originally Maxwell and Adam Saffron, and then Chris Fields got involved, and then he rewrote it and took out this figure. But I like this figure, which was in the original pre-printed one that was never actually submitted anywhere because people shouted at it too much. But I still like this figure because it allows you to talk in a way that people like Thomas Metzinger would understand. When you're talking about the epistemic depth being a global setting of the precisions that coordinate and contextualize all the hierarchical message passing, in virtue of the fact you have a hierarchy, you now have a series of nested Markov blankets. And furthermore, as such, you can always identify the active states of any Markov blanket at any hierarchical level, which means that you can look at the precision control, the broadcasting, the spraying as action, which means that because it's on the inside, you've now got a metaphor for mental action. So what you are saying is that epistemic depth is only manifest or realizable in the context of mental action, and that this mental action is a necessary aspect to render that which was transparent opaque. And that's the kind of phenomenology that Thomas Metzinger would say, oh, I see. But it also allows you to use the word mental action. And I think that would probably be one bright line that distinguished things that did and did not have mental action. I don't think a thermostat's got mental action. And I don't think, I suspect that David Hyland's not in anymore because we've been talking for so long, but I don't think the market has mental action in it, because mental action is the kind of action below you, or possibly globally, everything below you from the point of view of your large phi, that just represents the precision or the uncertainty. So if you're talking to David about the market, it's the confidence. So what you are doing is you're acting in a way that on the markets in a way that changes their confidence. Which means you have to estimate the confidence. So it's not the content, it's not what you're buying, it's the confidence with which you are buying. I repeat, I don't think that not all tiny creatures will have that capacity. And certainly things like viruses probably will not have that capacity. I may be wrong, but certainly thermostats don't, because they don't have a representation of their uncertainty. They don't have a representation of their confidence. So that brings me to the sort of back to your original definition, original focus on knowing what you know. One way of unpacking that is that it's not just knowing knowledge. It's, I think, something quite specific which you're bringing to the table here, which is knowing uncertainty, or knowing the nature of not knowing. And I think, you could argue that any hierarchical predictive processing or active inference scheme has all this recurrence in it, and so what's in terms of belief updating, for example, take David Harlan's question about the circular causality in any sort of exchange between two separable systems. Surely that circular causality is found everywhere, and yes, it is, but you're talking about a very special kind of circular causality where the action is not about the content, it's about the context, which is specifically the confidence or uncertainty. So it's knowing what you don't know, or more specific. Yes, you could say that if uncertainty is a description of what you don't know, then it's really knowing what you don't know. And the reason I emphasize that is that then you can draw the dots with sorry, no, we'll come back to that. No, let's not get rid of this. Yeah, this was shown during your presentation, and I forgot to show it before, but for the people who missed this, this would be this is Thomas Parr's description of how neuromodulators get into the processes that set the precision of belief updating hierarchically, not for predictive coding. So we're not talking about precision weighted prediction errors anymore, but exactly the same maths applies to discrete state space models like Markov decision processes. And he sort of takes you through the maths of the process theory, and then links it to various classical neuromodulators. Where's the maths gone? Oh, it's all not displayed. Never mind. So that's that. So I can get rid of that. Yeah. So I'm just sort of again trying to join the dots, because if you can join the dots with Mark Soames, I think that will put you in a very comfortable position of making friends with yet another person who's quite a player in the consciousness field of a very pragmatic neurobiologically and actually neuropsychologically informed kind. And what he focuses on, as I'm sure you know, is not so much the generation of phi, but its mediation and implementation through the classical neuromodulated transmitter space, the systems that actually do the spraying. And the reason I sort of bring him to the table is that because he associates consciousness or qualitative experience with the feeling of the experiential feeling, he associates the feeling as being realized by the precision, the things that are mediating the precision, which just are the things that do the ignition, which are, are likely to be the classical ascending neuromodulatory systems that kick off everything else that we've been talking about, and has the wonderful phrase felt uncertainty. So I think you should leverage that, because your phi is basically encoding the complement of uncertainty, which is precision. It's basically physicalizing, explicitly representing the known unknowns as part of this recursion, which is not, it is not the gift of just any recursive predictive processing, or, and I repeat, you won't find it in a thermostat. This is quite high order, and it has to be high order. So in being high order, it is only the province of large things. So again, you can appeal to the renormalization group to notice that this kind of mechanics can only occur at least in a multicellular organism, but I would actually say that has some hierarchical depth. So just by calling it epistemic depth and appealing to the notion of hierarchical depth, you're immediately talking about big things. So tiny creatures can't have this because they don't have the necessary scale. So again, we come back to this scale, the emergence at higher scales of the phenomena that you're talking about. But anyway, coming back to this felt uncertainty. So what Mark does, he says that the very spraying of the products of your own third uncertainty, what you don't know, the broadcasting of what you know about what you don't know in terms of uncertainty, is the feeling. which starts to get quite close to your argument that these are special kinds of belief updatings that would be unique to this kind of creature that had this capacity. You probably won't agree with him because your focus is not on the drive to the sprayer. Your focus is not on the action of the sprayer. It's what's driving the sprayer. So Mark likes to focus on the sprayer and the subcortex and say that's where feelings come from. Whether you'd say, well, it's more important what's actually driving the cause of the sprayer, which of course would be the sort of possibly a more cortical. Although somebody did say, look, perhaps it might not be. It might be much simpler than that. It might actually be in the subcortex. It might be in the cells of origin of these classical modulatory ascending neurotransmitter systems, things like the substantia nigra, nucleus basalis and Meinhardt, VTA, and all of these sort of classic brainstem structures or subcortical structures. But I repeat, I put this up just to sort of highlight this notion of building explicit representations and beliefs about your own uncertainty, about your own precision. One interesting thing that emerged for me in I'll just quickly explain why I put this up. At one point in your presentation, you used the analogy that when I talk, I hear myself talk, and there's a certain recursion in that. I know what you meant, but I would not use that example because the whole field of sensory attenuation means that you actually attenuate the consequences of your own actions so that you can realize it. So in fact, we don't hear ourselves talk in the fully blown sense that I would hear you talk. I have to attend to you to listen, but to speak, I have to ignore the consequences of my I have to disattend to the consequences of my action in order to act. So just a little technical thing, if you didn't want to upset psychophysicists, try and find some sort of deeper and more generic kind of self-monitoring or self-recursion, as opposed to acts on the physical world. I just put that in there just to remind myself to say that. And I just put this up here because it speaks to the final point, which is basically what you are bringing to the table. The epistemic depth is this explicit anticipation of the attentional set that is distributed throughout my hierarchy that realizes what I know about what I don't know, or about the precision or the second order aspects of my knowledge. The anticipation, I think, is important here, because what that means is you can now appeal to active inference where you select the right phi on the basis of the expected resolution of uncertainty. So remember, phi equips every level with the right precision, the right estimate of uncertainty, and you could say felt uncertainty, manifest felt uncertainty, and to be able to broadcast or spray that precision, you need to, or you can tell a story that you are going to do so in a way that maximizes the resolution of uncertainty. And of course, that's just the information gain. So you kind of appeal to vanilla active inference to say that it is interesting to think about whether phi, being the thing that's driving the sprayer, is itself the consequences of a policy where the policy is to establish the right attentional set. And if it is, then you're selecting the policy that maximally reduces uncertainty. So there's another sort of recursion here. It's getting quite complicated, but it's likely that's exactly what we do. We actually have to subconsciously or unconsciously, subpersonally at least, select the attentional set. And in so selecting, we may then have the self-awareness. This is the potential set. I'm anxious. I'm embarrassed. I should be focusing on this. I should be focusing on that. Oh, I'm looking at this. Oh, I'm looking at that. But to have that illusion of selfhood in this particular context means that you have selected one among many states of attentional sets, and in so doing, you can. It should be the case, if the free energy principle is correct, that you have done that selection on the basis of how much uncertainty you can resolve. So you might want to appeal to that or not. The reason I put this paper up is that I think the next section actually talks not about strange, beautiful loops, but strange loops. Oh, I can't find it.
I really should have mentioned Hofstadter in the talk, because of course Beautiful Loops was a play on his Strange Loops that I read.
Absolutely.
I read in my undergrad, and it was super influential.
And I play the same trick here in terms of strange loops. But the equation I was showing with the expected free energy and the resolution uncertainty is a generic one. It's just I was hoping to show you my attempt to nod to strange loops in the Hofstadter sense. But the one point which only occurred to me during the question and answering is that phi, as articulated in the questions, and to answer the last question or one of the last questions, what does that mean for the updating of phi? And Shamil answered absolutely correctly that, sorry, both of you answered absolutely correctly that as soon as you have phi as a latent state of the world, then there will be an approximate posterior that enables you to believe update about phi, and that updating will be dependent upon messages to everywhere that phi is sprayed. So one simple mathematical fact in self-evidencing or variational free energy minimizing or variational message passing in the brain or anywhere else is that if I change you, you change me. There's always recurrent message passing. So you know immediately that phi as some latent state of being, if it's sprayed everywhere, which it has to be by definition, else it wouldn't be global, it means that it is being informed by everywhere that it sprays to. So it will have to be somewhere in the brain that has access monosynaptically or vicariously to everything else. So you are looking at possibly subcortical structures. I got a proposal from Henry Mark, well, some colleagues who study anatomical connectivity, suggesting it's going to be the claustrum as a nod to Christoph Koch and friends. But you're looking at something that has access to everything, because it's going to have to receive all the, exactly as I think Ruben would say, it receives all the prediction errors effectively, all the free energy gradients from everywhere else. And that basically puts you in the position now of phi just being another hidden state. So because it's written down and described as a precision, I'm just wondering whether you should just point out that yes, it enacts and sets the precision for message passing later on, but it's just another latent state of being that is being inferred. And as such, it is not only private to me, but it's private to my knowledge about me, private to my knowledge in the sense that it actually estimates my uncertainty or my precision or my confidence, the nature of my knowledge. So it's clearly a very special kind of latent state representation that you could imagine being having a number of different, being multivariate. So it doesn't just have to be a global thing. It could be me in this attentional set, me in that attentional set, me. So an elemental kind of self-modeling. And if I know exactly, I've got all these messages from all the targets of my spraying, and I've assembled them over a long period of time. I'm now in this context because, and that means that I will anticipate being in this attentional set. And then I can now instruct all the neuromodulator systems to broadcast and do the spraying, and then you close your beautiful loop. But what interpretation of that capital Phi is really an inference, an illusion, whatever you want to call it, a posterior belief that I am in this attentional set, or this state of ignorance, or this state of knowing, or this state of intentionality, because it's all anticipatory, or I anticipate that my attentional set for the next few seconds or minutes will be of this kind. That gives you, I think, a sort of it may give some people an intuition as to how on earth self-modeling gets into the game in this second order. And I say second order because statistically the precision of the uncertainty is a second order statistic. It doesn't tell you anything about the content or the mean of a distribution. It just tells you about the quality of that distribution and how much you don't know given the support of that distribution. So that might be one way of unpacking how one can think about phi in and of itself before it's done its phi sub 1, phi sub 2, phi sub 3 for all the hierarchical levels. What's driving that? And of course, what is driving that is not only the belief updating of phi itself, but everything else that is a target of the spraying. So it's global in a global workspace sense, global neuronal workspace sense as well. So it has to listen to all the fields before it decides which to select or which to ignite. Good. That's all I have.
Just one quick thing on, you mentioned about the localization, that where do these things come together spatially in the brain? But actually, what we're talking about is information has to come through, but that doesn't necessarily have to be localized, in the sense that in emergent systems, you talked about the kind of coarse graining. If you have emergent systems where a network as a whole has more, for example, as in the sense of IIT, has more cause-effect information as a whole than subparts. It could be that this information is known, widely distributed. Sort of, it knows that it knows. There's in a technical sense, there's mutual information from one part of the subnetwork to the other part, and so this information is widely shared. And so, in a sense, it doesn't necessarily mean that there has to be a spatial point that all the information comes together. Couldn't it be that if we look at it in terms of information that's had by a kind of a macroscopic top-down network, that could be effectively the locus of what kind of informational system is spraying? Does it have to be localized?
I think it'd be easier to answer that question just by teasing, does the divergent spraying have to be localized? And I would say yes, absolutely, because you need to have that specificity to do the selection.
Right.
So you have to have spatially distinct targets of the spraying, because you're going to be spraying here but not here to do that attentional selection or precision selection. So I think if you like, the outputs of this system have to be. The question is, you're asking, what about the inputs, though? I think in principle you're absolutely right. You could imagine, in a very simple-minded way, certain global physiological variables, say the the amount of certain steroids in my bloodstream, or stuff that can get through the blood-brain barrier, gathering information from everywhere and channeling it to the origin of the spraying, the efferent, sorry, the outgoing part of the system. So absolutely in that sense, and of course, at its most spatially extensive, the ephaptic route, could be imagined. You could have complete coherence, say in slow wave sleep, for example. You could have information transmission of an emergent kind, of a macroscopic kind, that was mediated through traveling waves in the cortex, and that it's something that Julia Tononi would certainly it would be something that he's studied to a certain extent, and perhaps Robert can comment on that. Having said that, although I love the magic of the renormalization group and emergentism, when it comes to actually simulating these things, it's always message passing on a factor graph, and that factor graph is always sparse because that's what defines the Markov blankets and the hierarchies. So for me, it's more than likely, I think, that there is an anatomical correlate of these things, to be quite honest, because it's conserved. It's part of the cause-effect structure that's been specifiable epigenetically and has to be an anatomical structure simply to get that sparse connectivity. We heard the intriguing notion, is the pancreas conscious in this sense? And of course, what's the difference between your brain and the pancreas? The brain can have action at a distance, just because it's got very sparse long-range connectivity, has neurons, whereas the liver and the pancreas doesn't. The heart does, interestingly. It does actually have some, well, actually no, it's all traveling waves. So I think there's something special about the physical architecture of the brain, which says that if you want to come together, you've got to come together in a very sparse way. So I don't think it's the claustrum. I don't think it's the pineal gland. I don't think it's the nucleus raphe. I think it's absolutely distributed, but it's still distributed amongst definable and dissectable anatomical structures upon which the dynamics play. So yes, it's certainly emergent, but it's emergent, I think, on a very structured anatomy.
Right. In a sense, you might be thinking, I mean, maybe like the default mode network, or there's some sort of emergence, but it ends up being localized somehow.
Yeah, so it could be gathered, but I'm thinking, of course, if it does become non-local, then you'd probably lose fine consciousness, which is what slow wave sleep is. I think it is the very specialization and the careful gathering of the right kind of information by this higher ordered, possibly distributed system that actually underwrites its function. Just from a purely sort of the part of the consciousness community that just deals with levels of consciousness from the point of view of anesthesia, what you generally see is as consciousness goes down on all three levels of your three-dimensional structure, things become more coherent and they become much slower, like Creutzfeldt-Jakob disease or coma or deep sleep, and ultimately, of course, death would be the ultimate synchronization. So my suspicion is that you're still in the game of thinking about the actual neuroanatomy of consciousness. It's not going to be one thing. I'm mindful here of arguments with Chris Fields, where he would argue that phi is by exactly the arguments we're talking about in terms of the variational message passing, because epistemic depth is global. It means that it has to get information from all levels of the hierarchy, which means that the thing doing phi can't have any hierarchical structure. Otherwise, it would have to get information from itself. And therefore you wouldn't be able to factorize it, which leads to the notion of an irreducible Markov blanket somewhere. Not necessarily compact in space, but informationally, there has to be an irreducible Markov blanket in the core, if you like, and there may be more than one core. Maybe one for each hemisphere, or one for the pancreas possibly. But there has to, from his point of view, the inner screen is the Markov blanket that is of an inner Markov blanket that is irreducible, and then you have to ask yourself, well, what must that Markov blanket entail? And it has to entail the sprayers. It has to do the mental action that's doing the spraying. The question is, of course, is what's on the interior of this irreducible Markov blanket, which is what you're asking. I don't know.
It's very interesting phenomenologically. When advanced meditators are able to go into a sort of a pure awareness type space, there is a kind of a similar to minimal phenomenal experience of Thomas Metzinger, as an epistemic field or an epistemic space, everything that knows. But the interesting thing is that itself can't be an object for itself. Well, we put it in the paper, it illuminates itself, but it's not. It's sort of a little bit like that. Chris Field's, I can't remember the name of the paper, the sort of mirrors.
Inner screen hypothesis.
Inner screen, right. The top screen, in a sense, can't be an object for itself.
Yes.
Yeah.
Which could be nicely related to the smart glasses and that graphic with the, there was a top glass, if you like, and of course you can't put another one on top because then the top is, so you have an inner screen in your graphics already. That's
yeah. I mean, yeah, it's an interesting point, but yeah, this is fantastic stuff. I'm so glad it's recorded.
Carl, so one structure that came to my mind when I heard you talk, I mean, recognize that this is certainly distributed and it's not one spot only, but one structure of big interest would be the higher order thalamus. I mean, I suspect, I mean, I'm not sure whether Henry Markram mentioned that to you, or because you didn't say the structure specifically, but it's the projections from the higher order thalamus to the association cortices, and especially the projections towards the layer 5B pyramidal neurons, layer 2 and 3 pyramidal neurons, which when you have anesthetic effects, you target the coupling compartment of those neurons and you are out. But then if you stimulate the higher order thalamus, you can wake people up from anesthesia with anesthetic level concentrations of substances in their bloodstream, which is quite important. And it's higher order thalamus stimulation that does that.
Well, that's very interesting. So in fact, Henry did in fact say that the connectivity of the claustrum mirrors very much certain parts of thalamocortical and subcortical connectivity. Yeah, he made that that analogy explicitly in the proposal that I read, and just to also sort of lend more power to that kind of argument. Of course, things like the Pulvina have been implicated in terms of the searchlight hypothesis of consciousness in attentional. So it's like that would be one clear candidate. I have to say that those are probably candidates for the sprayer, the Markov blanket of what Shamil's chasing. It doesn't. I don't think that these in and of themselves are really going to be the locus of the computation of phi. But there certainly will be the endpoint of the outflow or the efference from the system. So that, yes, I'd forgotten that. Yeah. So and I suppose yeah. So I was just going off in terms of the nucleus reticularis and the like, but that's me being a neurobiologist. I have to stop. Yeah.
All right. So with that being said, let's have one final round of applause for Ruben and for the authors of the paper as well. All right. So we will share with you, Ruben and Shamil, we will share the recording. We will upload it on YouTube, but it won't be public until the publication is up. And yeah, thank you all very much. And we will see you with the next occasion, hopefully soon, with the second version of the beautiful loop theory.
And before we go, I just thank you again for the invitation. And Carl, I just like wrote an essay of notes from everything that you said. That was super rich. Very helpful directions, both in terms of just thinking about this practically, but also some of the things you said around attentional sets and selecting attentional sets. These are like very intuitive ways to begin to think about and talk about this idea to a larger audience, which I think it helps a lot. So super rich, super helpful, and I'm grateful for this this time.
Yeah, well, don't make it too intuitive. There's a certain magic and mystery which you should try to maintain to a certain extent. But yes, well, thank you, sir. I'm joking. Thank you. I really enjoyed this afternoon's session. So to the two of you and of course our marvelous chair. Thank you very much. And I'll see you soon.
See you soon.
Yeah.
Bye.
So.